Okay, so this is partial fractions. This is partial fractions. What that means is you're going to take a fraction and rewrite it as a sum of difference of two or more fractions. Right? So this is really just an algebraic technique. The initial steps are not really calculus; it's just algebra. But it's not studied in algebra because it's not that useful. You usually go the other way. You just take two fractions and add them together and make one fraction. So we're doing the opposite. We're decomposing a fraction. And here's the basic technique. So I'm not doing calculus right now. I'm just doing algebra. And this is the basic technique. First of all, you got to be able to factor this. If you can't factor, then you got to look for another technique. All right. So this is easily factorable. You can factor it into x plus 2 and x minus 1. Now, the thing is, you don't know what the numerator is. Only thing you do know is that there is no x in the numerator. Okay, that is a given. There's some rule in algebra that says if that is the answer, there is no x in the numerator for these two fractions. Okay, all right. I don't know what the rule is. Take my word for it. All right. Okay, now what I'm going to do is multiply through by the common denominator, which of course is the x squared plus x minus 2. Right, so because this trinomial contains these two binomials, because these are factors of that. All right, so if I multiply through by the common denominator, on the left-hand side, I get 1. On the right-hand side, it becomes a times x minus 1 and b times x plus 2. Right? So I end up basically multiplying the numerator by the factor that's missing. Right, so a times x minus 1 and b times x plus 2. That's not 21, that's 2. All right. Now what you're going to do is figure out what a and b are. So that's what's the point of that. We need to solve for what a and b are. Well, that's easy. We're going to let x equal 1. Now, this is the weird part. If x equals 1, it makes it undefined. Well, don't worry about that. All right, if I let x equal 1, the left side is 1. The right side, the a gets wiped out because 1 minus 1 is 0. So a times 0 is 0. So I'm left with this side. Right? I'm going to plug in 1 here. 1 plus 2 makes 3, so it's 3b. So that means b is 1/3. Now we let x equals negative 2. Right. The whole point is I want to wipe out a variable. When I say variable, I want to wipe out b or a. So this time I'm wiping out b by putting x equals negative 2 in there. That's going to give me 1 on the left. And on the right, it would be a times negative 2 minus 1, which is negative 3. And on the b, it gets wiped out because negative 2 plus 2 is 0. Remember, that was the whole point. The whole point of me choosing negative 2 for x is to wipe out that variable. So that means a equals negative 1/3. Alright, so that means I can rewrite this fraction as negative 1/3. And I'm going to write it kind of sloppy here. Right? Fractions and fractions are usually not a good idea, but just to keep things simple. That's it. So whatever I get for the a and b, I just put it right in the numerator, right? Remember, I got a is negative 1/3 and b is positive 1/3, so that's what I put. All right, so that means what I have. So that means this is the integral, and I'm going to clean this up a little bit. I'm going to take a negative 1/3 out of 1 over x plus 2 dx, plus take the positive 1/3 out, 1 over x minus 1 dx. That's the whole point of that, right? So this fraction is the same as these two added together. And remember, you can split integral. Well, you don't have to split it. You can rewrite it here. If you left it like this, it's not wrong. Negative 1/3 over x plus 2 dx. Oops. Plus 1/3 over x minus 1 and then dx. You can leave it like that. If you're more comfortable with that, that's fine. Now, what I'm going to do is integrate this. Integrate this. Right? Remember, that's easy. Whenever it's a linear binomial in the denominator, it's just going to be the natural log of that. Okay? Or if there's a number in front of the variable x, then you might have to compensate for that. But that's about it. But this example is just natural log. So I'll put my answer down here. So it equals negative 1/3. The integral of 1 over x plus 2 is the natural log of absolute value of x plus 2. And then this one is natural log of absolute value of x minus 1 plus c. Okay, now they might do something with this, like for example, they could factor out a negative 1/3. Notice I'm factoring a negative 1/3. If I do that, this part turns into a negative. Right? So natural log of x plus 2. If you factor out a negative out a positive, it makes it a negative. And I'm not worried about the plus c. Okay. Now, the reason why I did this, because once you get it here, you can rewrite it as one natural log. So at this point, I'm really just doing algebra. So it's the absolute value of x plus 2 over x minus 1. Remember your properties of logarithms. When it's a difference of two logs, you write it as a fraction, as a rational expression. And that's it. You could put in the cube root in there, but that's probably okay. So that's it. That's example 1 of partial fractions.